In this video, I'm going to go over number 42 on page 216, curve sketching for trig functions. So first, we're given the domain between 0 and pi. Here's our function, 2 parentheses x minus 2 plus cotangent of x. I'm going to go ahead and distribute that through, make it 2x minus 4 plus cotangent of x. Now let's think about restrictions for cotangent. Okay. There's vertical asymptotes at 0 and pi, and that's exactly also where the domain for our graph is going to exist, or given in the problem. Okay. So we're going to find information about increasing, decreasing, relative max, relative min, point of inflection, concavity. So let's first start off with y prime to get to our sign line for our first derivative. So y prime, I'm going to look at this expanded function to find the derivative. So 2x turns into 2, 4 goes to 0, cotangent becomes negative cosecant squared of x. Right? Once we have our derivative, we're going to find our critical point, so we set our derivative equal to 0. And I'm also going to rewrite cosecant as 1 over sine squared of x. So set that equal to 0. Take steps to get sine of x by itself. Okay, I can move the sine over to with the 2 and then divide both sides by 2. So sine squared of x equals 1/2. Take the square root of both sides. Sine of x equals square root of 1 over 2, which is same thing as root 2 over 2. We recognize that to be values that we can figure out. So sine of x equals to root 2 over 2 at pi over 4 and at 3 pi over 4. And keep in mind that technically this is going to occur in all 4 quadrants, but we have to keep in mind that we have to keep our domain as our restrictions. So we have our critical points, pi over 4, 3 pi over 4, create our sign line. Endpoints at 0 and pi, critical points at pi over 4, 3 pi over 4. So now we got to test values with our derivative. Okay, I'm going to test values with the sine squared x, 2 minus 1 over sine squared x. Just a little bit easier to figure out values in terms of sine. So if I choose a value between 0 and pi over 4, let's say I chose pi over 6. Right? If I choose pi over 6, sine of pi over 6 is going to be 1/2, and so 1/2 squared is going to be 1/4, and if I flip that, that will become 2 minus 4, which is negative 2. So I know I'm going to get a negative value in this interval. Here between pi over 4 and 3 pi over 4, I can choose pi over 2. Right? Sine of pi over 2 is 1, 1 squared is 1, 2 minus 1 is 1, so that's positive. Here I can choose a value between 3 pi over 4 and pi. I can choose 5 pi over 6. Right? 5 pi over 6 will give me the same result. I'm going to get 1/4. 2 minus reciprocal 1/4 is 4, so 2 minus 4 is negative 2. So again, negative slope there. Okay? Based off the sign line, I can write statements about decrease and increasing interval. So decreasing in these two intervals. Okay, so I write that because f prime is less than 0. Increasing in this interval from pi over 4 to 3 pi over 4 because f prime is positive. Okay. And relative max, I can tell by looking at my slope that I'll get a relative min at pi over 4 and I'll get a relative max at 3 pi over 4. And if I want to identify relative max first at 3 pi over 4 because f prime changes from positive to negative, and relative min at pi over 4 because f prime changes from negative to positive. And if I want to find my y values, I'll have to take 3 pi over 4 and plug into my original equation, and that will get me 3 pi over 2 minus 5. Okay, easy way to evaluate this without having to use a calculator. Think of pi as number close to 3, so 3 times 3 is 9, 9 over 2 is 4.5, 4.5 minus 5 is negative 0.5, so this is roughly about negative 1/2. Relative min, pi over 2 is 3 over 2, 1.5 minus 3, would be roughly around negative 1.5. Okay, so we'll keep that in mind as we when we're ready to sketch. Okay. All right. So moving on to second derivative, I'm going to, before I find the derivative, I'm going to choose to use 2 minus cosecant x quantity squared. It's just going to be a little bit easier to just go through chain rule instead of having to go through quotient rule. So derivative, 2 goes to 0. Here we got to deal with the 2 first. Chain rule, bring down the 2, keep the bracket, and then multiply by the derivative of cosecant of x, which is negative cosecant cotangent. And all this combines, 2 negatives cancels out, so I'm left with 2 cosecant squared x, cotangent x equals 0. I have 2 functions equal to 0, so I can set both pieces equal to 0 separately to find my critical point. Cosecant squared of x equals 0. Cosecant x is never going to be equal to 0. That's the same thing as saying that sine is equal to 1 over 0, which does not exist. Okay. And cotangent of x equal to 0, that's going to occur at pi over 2, so this is going to be the only critical point. My endpoints at 0 and pi, my critical points at pi over 2, plug pi over 4 into my derivative, into my second derivative to determine concavity. Now, between 0 and pi over 2, this is the first quadrant, right? And I know that everything's going to be positive in the first quadrant. So cosecant is similar to sine, so that's a positive. Cotangent is similar to cotangent, positive, so 2 positive gives me positive. Pi over 2, between pi over 2 and pi, any value I choose, it's going to be in the second quadrant. And if you think about second quadrant values, sine will always produce positive values in the second quadrant. So sine, I think of sine similar to cosecant. Cotangent is similar to tangent, but tangent will always produce a negative value in the second quadrant. So positive times negative is negative, so concave down. Okay. Point of inflection at pi over 2, we know that because there's a change in concavity. F double prime changes signs. So plug pi over 2 into the original equation, and you'll get pi minus 4. Think of pi minus 4 as 3 minus 4, which is negative 1, so y value negative 1. Okay. Now, if I put everything, all my critical points on the same sign line, as well as concavity and increase, decrease, then I can use this to sketch my graph. Okay. Relative min is going to occur at roughly negative point. Relative min is going to occur at negative 1.5. We know that point of inflection is going to occur at roughly negative 1. And then relative max is going to occur at roughly y value of negative 0.5. Okay, so we just follow the graph's information, concavity and slope. So decreasing, concave up, increasing, concave up, hits a point of inflection, increasing, concave down, and then decreasing, concave down. Okay, with asymptotes at 0 and at pi.